So today we're going to talk about density. Before we get to density, though, there's two terms I want to define. We had talked about them yesterday. You guys wrote them down in your lab report, the definitions of these, but write them down again in your notes so that you have them for later. Two words are mass and volume. Mass, definition. It's the amount of matter is material, that's in an object. The amount of matter that's in an object. Now, mass is slightly different from weight, but the confusion usually lies in not what the word mass means. Usually it's what the word weight means. Most people, when they think of weight, they're usually actually thinking of mass. So, if I were to tell you guys I weighed 150 pounds, right, which I don't, but if I weighed 150 pounds, that means I have 150 pounds of material in my body, right? Well, that would be mass. Weight actually, scientifically, refers to the force of gravity on something. So, gravity changes depending on where you are on Earth, or even if you leave the Earth. It will actually change in different situations. Like when you're in a car and it's accelerating, do you guys know that feel where you're being pushed back? Your weight is actually increasing at that point because of the acceleration of the car. You actually weigh more while it's accelerating. Decelerating, you have to kind of weigh less. Like you're like, woo! You guys know what I'm talking about? So mass is actually the amount of material. That's usually what people refer to when they talk about weight. Volume is the amount of space an object will take up. The amount of space an object will occupy. This is also known as its size. So when I refer to volume, I'm talking about how large or small it is. It is perfectly possible to have a large object with not a lot of mass. For example, a beach ball. That is actually pretty large, but it doesn't weigh a lot. There's not a lot of mass there. It's mostly filled with air. Versus, say, a bowling ball, which is actually kind of smaller than a beach ball, but definitely weighs more than a beach ball. There's a lot more material in a bowling ball. Okay? I'll wait 1 second. People are still writing. So this gets us to density. Density is defined as the amount of matter in a given amount of space for a substance. The amount of matter in a given amount of space for a substance. Density is basically combining both ideas about mass and volume together. So when I talk about density, I'm talking about, hey, I have this much mass, but also this is how much space it's going to take up. It's more like how compact something is, how spaced out the matter is in that object. Density is going to be the same for everything made of that substance. So if I have, say, aluminum, I have a block of aluminum. Here's a block of aluminum. This has a specific density. It has a specific size and a specific mass, but its spacing of the atoms inside this block of aluminum is unique to aluminum. So if I had another block of aluminum exactly this same size, it would be exactly the same mass. The spacing of all those atoms would be the same. If I were to have a larger chunk of aluminum, this is a bigger one, this bigger is going to weigh more. But the spacing of the atoms are the same, and if I were to cut off a piece exactly the same size, it would weigh the same. So density is more like about spacing of the materials. It's how compact or spread out the material in it is. That's what density is about. So I've got three objects here. Okay. This first one here is a block of aluminum. The next one is a block of brass. And then the third one is a block of aluminum again. Now the aluminum block, the last one, is a lot bigger than the other two. Okay? You guys have a picture of these in your notes. Right? Of these two, the first one, the small aluminum, and the brass, they are actually the exact same size. They're identical sizes, but the brass is got a lot more mass. So that means there's a lot more material packed into here than there is in here. Now, how could that be possible? How can you pack more material into the same amount of space? Chemical makeup. I mean, they're made out of different substances. What do you guys think the atoms of this look like? A lot closer together on the brass, right? So if I were to draw these, I want you guys to actually draw atoms here. I'm going to draw blue ones for the aluminum. So there's some atoms for the aluminum. I'm going to space them out like that. I think I got 6 by 6 there. You can kind of space out however you want. Make sure they're a little spread out though, because the brass has to fit more in there. Okay, so I'm going to cram more in the exact same amount of space there for the brass. This makes it heavier, since it's the same size. It makes it denser. Denser means they're packed closer together. Now the last one, this bigger aluminum block, this is larger, so it has more mass. This is, in fact, heavier than this aluminum block, the first one. So we're going to have to draw more particles here. There's more material here, but it's also larger, so the spacing here should be identical to the first one. It's the same material. They have the same density, so the spacing, and if I only draw it like 6 by 6 like I did the first one, you can see that it would be exactly the same size. Like this piece here, right here, looks identical to this piece here. Okay? It's just happened to continue going because it's a larger object. So I'm just going to draw a line and continue going. The spacing is what the density is. How much material is there packed into that space? Now, if we had a different object besides this one and the aluminum, let's say we had a fourth one that was a dense object as well, denser than this. Let's say it's lead. Okay, let's say I have a fourth object that's lead, but same size as these. I'm not sure I could pack that any closer. Do you guys see that? That's pretty packed closer. So how could you fit more material in here if it was lead? Any ideas? Jasper?
Use different shapes to signify times 10 or times 100 or something.
Okay, so like try and, but let's say this is what the spacing actually like is. How could lead possibly be heavier? This is as close as I can get. Andrew? I can make smaller ones to get them even closer. Or I can make bigger ones, which would weigh more, right? Like, it's about getting more material in there. So you kind of have to look at how much material is packed in there. If the atom itself is going to be heavier, has more mass, even if the spacing's the same, it's going to be denser because there is more material packed in there. So it's not all just about spacing. It could also be we have different sized particles. It's all about how much material you have packed in there. Okay? There's a question on your homework on that, so I wanted to kind of clarify. It's all about the material. Okay, now you can calculate density. There's a formula. You may have heard it before. Density is equal to the mass divided by the volume. You take whatever mass an object weighs, and then you divide it by the volume of that object, you're going to get density. The units for this, for density, are grams per milliliter, or grams per centimeters cubed. A centimeter cubed and a milliliter are the same thing, so these are basically the same unit. So, I want you guys to take a look at the next page. There's a chart up at the top with some measurements, just like you did yesterday in the lab. They did 5 objects. They measured their mass, and they measured their volume. They started with the smallest and went to the largest. So the first one, the mass was 15 grams. The next one, mass was 15 grams and 2 centimeters cubed. And then it was 60 grams, 8 centimeters cubed, so on and so forth. What I want you guys to do, that first object, number 1, what's the density? I just told you how to calculate it a minute ago. I want you to calculate the density, please. So density is mass divided by volume. So 15 grams divided by 2 centimeters cubed. 7.5 grams per centimeter cubed. Okay? Let's do the next object. 60 grams divided by 8 centimeters cubed.
Same exact answer.
Same exact answer. What does that tell you about those 2 objects? They have the same density.
Same material.
They're probably the same material. One's just a larger version of that exact same object. So the next one?
Are the same.
Same again. These are actually all 7.5 grams per centimeter cubed, so all of these are made out of the same material, even though they're all different sizes and different masses. Okay? Next, I want to take a look at that graph down below. Kind of write that down, they're all the same substance. So take a look at this graph down below. I want to graph these points on there. You as well. The first one, 15 grams and 2 centimeters cubed. That would go about there. About 2 centimeters over and about 15 up. Each line's 100 here. That one's 200. So it's going to kind of get a little crowded here, but way down here, like 2 centimeters, about 15 grams. Okay. The next dot, 8 centimeters and 60 grams. So a little higher up. Next dot is, I can't remember. I got it on there, but 120 grams and 16 centimeters. So 120 is about there, and 16 centimeters is about there. You guys starting to see a pattern emerge? What's the pattern? It's a nice straight line kind of going up, right? Next dot, be about there. That's 480 grams, 64 centimeters cubed. The last object would go about there. 750 grams and 100 centimeters cubed. So we've got a nice pattern going on here. I'm going to draw a line of best fit. A line of best fit should be a straight line, not connecting the dots. Don't ever connect the dots in chemistry. Don't connect the dots, don't connect the dots, don't connect the dots. How many of you guys connected the dots in your lab yesterday? You might want to go back and fix it, because I will be taking points off if you connected the dots. So you haven't turned it in yet, but don't ever connect the dots. I want you to draw a straight line that best fits this data. Now, I'm not the greatest grapher, so my dots might not perfectly hit the line, but that's a good line there, perfectly straight. Can you guys see that not every dot is perfect, though? Like, that's usually more graphing ability than anything. Okay? Don't connect the dots. Just straight line, best fit them as best as you can.
So even if it doesn't hit the...
You want to hit as many as you can. If it's like 2 that you just can't hit, try to like go between them or whatever. Okay, you try and get something that fits this pattern that you're seeing.
I'm extremely close. I'm just going to...
Okay. Now, density is the same for all of these objects. Yes, I have different masses and different volumes, but the density is the same for all 5 of them. What's the same about this? The pattern. Okay, the slope. So the slope in this graph, which you learned in algebra, that is actually the density. As you get more and more volume, you get larger and larger, you have more and more material packed in there. So the more material you get, the more space it's going to take up. Get more material, takes up more space. More material, takes up more space. So it's a pattern here. That slope is the density. And we just figured out the density a few minutes ago. What's the density here? 7.5 grams per centimeters cubed. So that is our slope. Now, if you guys want to write an equation for this line, the slope is 7.5. You guys know how to write an equation, y equals mx plus b, right? So m is our slope, that's 7.5. Do we have a y-intercept? Would it actually go and cross the y-axis here? I didn't really draw it all the way, but if it did, it would cross at 0, 0, right? It crossed at 0, 0, so b would be 0. So we're just going, hey, y equals mx plus b, b is 0. You don't really need a b. So really you just need y equals mx. So y equals 7.5x. There's your equation. If that helps you guys, hey, what's the slope? Well, figure out the equation. Figure out the equation, write it down. Slope is density. Okay? One other quick note. On your homework tonight, one of the questions, I actually ask you guys to graph a line, and the only information I give you is the density. So let's say I told you the density was 5 grams per centimeter cubed. That's the slope. Could you guys graph a line y equals 5x?
Yeah.
That's what you have to do. Does that make sense? You have to make that connection. Okay? If the density is 5 grams per centimeter cubed, and I ask you to graph it, you don't have to draw any dots or anything. All you got to do is go, okay, so y equals 5x. Draw that line, which you should know how to do from algebra. Okay? All right, below that, I got a couple of example problems. Example number 1. What would the mass of a sample of that same material in the chart above be if its volume was 75 centimeters cubed? Okay? I want to refresh your memory on exactly how I define density. So the density here is 7.5 grams per centimeter cubed. That means that each centimeter cubed weighs 7.5 grams. So if I had an object that was a centimeter cubed, it would have a mass of 7.5 grams. If I had an object that was 2 centimeters cubed, it'd be double that, 15, which is on one of our data points. Okay? 3 centimeters cubed, what's 7.5 times 3? 22.5. So it'd be 22.5 grams. So you can use this to figure out what 75 centimeter cubed would. So there's the density, 7.5 grams per centimeters cubed. I have 75 centimeters cubed. That's what each one weighs, 7.5. Since I have 75, I'm going to times that by 75. Okay? 7.5 times 75. Punch it into a calculator, please. Write down an answer. Answer, my calculator says 562.5 grams. But that answer's got 4 sig figs. How many sig figs am I allowed according to my measurements? 2. This only has 2, and this only has 2. So this can only have 2. So what would that be with only 2 sig figs? 560. Okay? Rounds down to 560. Now that is one way to solve this problem. There's actually another way to solve this problem, and it involves the graph. Since this is all on that graph, all this information is up on that graph. Let's go back to that graph and take a look. You could use this graph to answer the question. You should get the same answer. Okay? So how to do that? Well, it's 75 centimeters cubed, so I'm going to find 75 centimeters cubed this way, and I'm going to go up to the line. Right? And then all I have to do is go over to the y-axis where the mass is, from that point on the line, and look at where it is. That's approximately a little higher than 550, right? So it's approximately 560, which is what we just calculated. Make sense? There's two ways to solve this problem, because you have that graph. Okay? Next example. What is the mass of an object that takes up 575 centimeters cubed and has a density of 3.97 grams per centimeters cubed? So this is a different material. It's got a different density. My density is 3.97 grams per centimeter cubed. The volume is 575 centimeters cubed. I want you guys to give this one a try. It's just like the last one. So take a moment and get an answer. I want you to give me the answer. I want you to tell me what to do. What do I need to do to solve this? So take the 3.97 grams per centimeter cubed and times it by 575. Okay? That's how to solve this. When you punch that into a calculator, what's the answer? Abby? Okay, 2,282.75 is what my calculator said as well. Do I get that many sig figs though? No, this is multiplication, so I don't get 6 sig figs like that has. I only get how many? This one's got 3, and this one's got 3. So my worst one's 3, so I get 3. How would that round to 3 sig figs? 2,280. Okay, 2,280, 3 sig figs. All right, this last problem, I'm going to kind of focus on example 2 to try to explain it. What we did here is we multiplied the density by the volume here. So in order to find the mass, we multiplied the density by the volume. That's what you do in order to find mass. I don't know if you guys want to write that down as a little cheat sheet. But if you want to find mass, multiply density by the volume. Okay? Earlier I told you guys how to find density. Density, you take the mass and you divide it by the volume. That's how you'd find density if I asked you to calculate density. Mass of the object divided by the volume. Can you guys see those are the same equation, just rearranged? This is the same thing. I just rearranged it to figure out which one I wanted. So what I want you guys to do, volume this time. This question is asking the volume. What is the volume of an object that has a mass of 9.56 grams and a density of 1.75 grams per centimeter cubed? How can I rearrange the equation again, but this time get volume? Andrew? Mass divided by density. Okay? So to solve this problem, looking for the volume, you take the mass and you divide it by the density. Okay, so the mass is 9.56 grams. The density is 1.74 grams per centimeter cubed. So 9.56 divided by 1.74 equals ready? My calculator says 5.49425 like lots of numbers. Keeps going forever, right? We definitely don't get that many sig figs. How many sig figs do we get? We get 3. 9.56 only got 3. 1.74 has only got 3. So how would this round so it only has 3? You said it? 5.49. Okay, centimeters cubed. Questions?